Think about what your write path actually needs. To accept a withdrawal, it needs exactly one account. It needs that account's current balance, and it needs to enforce a rule. You cannot go below 0. It touches one thing, and it cares intensely about correctness. Now think about the read path. It needs a dashboard across 1,000,000 accounts, grouped by branch, sorted by risk, for a manager who will look at it for 8 seconds. It touches everything, and it cares about speed. Those are not the same system. They want different shapes, different indexes, different hardware, and different failure behavior. And in most architectures, we make them share one schema, and then wonder why neither is good. And here is the thing worth noticing. If you have been following this series, you already built this. The right side appends events to a stream and enforces its rules against one account. The red side has projections shaped for queries. You did not set out to do CQRS, you did it accidentally because event sourcing forces it. That is the honest relationship between these two patterns, and it is usually stated backwards. CQRS is not a prerequisite for event sourcing. It is a consequence of it. Once your truth is a log and your queries are projections, the separation is already there, and the acronym is just a name for the thing you are standing in. Look at how small the right side gets, because this is where the design earns its keep. To handle a command, you load one stream, fold it into just enough state to make a decision, check the rule, and append. That is it. There is no join, there is no report, there is no other account involved. And the whole operation touches a single stream, which means your consistency boundary is one account, and your locking is trivially scoped. Every complicated cross-entity query that normally lives in this layer has moved to the read side, where nobody's invariants depend on it. The write model gets to be small and strict is exactly what you want guarding money. The split also gives you something operationally that a shared schema never can. The two sides scale independently, and they need to, because their load is nothing alike. Reads outnumber writes by a wide margin in almost every real system, and now you can throw read replicas, caches, and denormalized tables at that without a single consequence for correctness, because none of it is authoritative. Meanwhile, the right side stays small and can often run on far less than you expect, because it is doing tiny, single-stream operations, and you can have as many red models as you have questions, each shaped for its own job, each rebuildable, none of them able to corrupt anything. Now the honest part. Because CQRS gets adopted by people who liked the diagram, without event sourcing, CQRS means keeping two models of the same data in sync yourself, and you have chosen a synchronization problem that you did not previously have. In exchange for query flexibility, you could probably have got from a view and an index. If your reads and writes genuinely have the same shape, and for most CRUD they do, then splitting them buys nothing and costs you two models to hold in your head and a class of bug where they disagree. The rule I would give you is this: let CQRS be something you notice you already have because the log forced it, not something you go and install. So the right side appends and the read side catches up. That word is carrying an enormous amount of weight, and it is about to cause the most common support ticket this architecture ever generates. The customer deposits money, reloads the page, and it is not there. Next episode: eventual consistency and how to explain it to people who hear it as sometimes wrong. See you there.